Hello everyone, welcome to lesson 413. Today's lesson is going to talk about systems of linear and nonlinear equations, and we're going to use multiple strategies to help us solve these systems of equations. All right, so let's talk first about what it means. What does it mean to solve a system, whether it's linear or nonlinear? What we're trying to do when we solve a system is we're trying to find values for x and y that will make all equations in the system true at the same time. So if you look at our examples down here, you notice we have two equations in most of these examples, and what we're trying to do is we're trying to find a value of x and y such that if I were to plug them in, right, to both equations would end up being true. All right. So that's what we're looking for when we solve. Now, another way that we could do this is by looking at the graph. So you can usually find the solutions to your systems by looking at the intersection points of the two equations that they give you. And I'll give you an example of that. So let's take a look at our first system and we'll see what we're doing here. Now make sure that you are paying attention to the instructions. So if they ask you to solve it algebraically, that means that you actually have to write out your equation steps and everything like that. Okay, so don't go to a graph and just state the solutions by looking at the intersection point, but you actually have to show the algebraic work. All right. So one method that we could use, since we want both of these equations to be true at the same time, one way that we could do that is by taking each of the equations and setting them equal to each other. All right, so I can take negative 5x plus 1 and set it equal to negative 2x minus 2, and I can do that because they are both equal to y. Right? So I can say negative 5x plus 1 equals negative 2x minus 2. And this creates an equation where I can draw a line and begin solving. Okay, and you might think, well, this is really similar to what we did in the last two sections. It's just that they weren't already broken into two equations for us, and you would actually be correct. It's almost no different than what we were doing before. It's like if we started with this equation, what we did was we broke it into two smaller equations like this, and then we graphed them. All right, so this time we're actually putting them back together so that we can algebraically solve. All right, so I'm going to go ahead and get x's. I'm going to get my x's on one side, put my numbers on the other side, and I'm going to keep making moves until I get x by itself. All right, so the first thing I'm going to do here is I'm going to add 2x to both sides. All right, to move the negative 2x over to the left. Okay, so when I add negative 5x and positive 2x, we get a negative 3x. We still have a plus 1. And then over here, the two x's cancel, and we're left with negative 2. All right, so now I'm going to take this positive 1. I'm going to move it over to the right-hand side. So I'm going to subtract 1 from both sides. And let's see what we end up with here. The 1's will cancel, leaving me with just negative 3x. And then over here, negative 2 minus 1 is negative 3. All right, so then to finish this off, this is multiplication here, so I'm going to undo that with division. So we're going to divide by negative 3 on both sides. The negative 3's cancel over here, leaving us with just x. And then negative 3 divided by negative 3 is a positive 1. All right, so what we have found is that x equals 1, but we are not done because this was a system. And remember, when we solve a system, we have to find values for x and y. That's why I bolded and underlined that. So you have to find x and y. Okay, and sorry, I did not mean to write a 1 there. So we have to find x and y, and to find y, I can take this value of x that I found, and I can plug it into either one of these equations. Okay, so I'm going to work with the first equation. So remember, according to the first equation, y equals negative 5x plus 1. Well, now we know what x is. X is 1. So I'm going to say y equals negative 5 times 1 plus 1. So then I use my order of operations here. Negative 5 times 1 is negative 5. And then negative 5 plus 1 is negative 4. So when I plugged a 1 in, I got a 4 out. So the solution to my system is going to be x equals 1 and y equals 4. And we can write that as an intersection point, 1, comma 4. All right, so it says here to think about what the solutions mean graphically. If I were to graph these two functions, this is where they would intersect at. And we can get the 1 and the 4 right from that intersection point. So let me show you what that looks like here on Desmos. Okay, so I went to Desmos, I graphed each of my equations here so you can see the lines pop up. And I'm going to focus in on the intersection point, which occurs right here. And if I click on that intersection point, you can see there's my 1 and negative 4. So my x value is 1, my y value is negative 4. So the graph, much quicker. But just make sure you pay attention to the directions. If they ask you to do it algebraically, I need to see all this stuff. If they ask you to do it graphically, that's me being nice to you and hoping like, hey, do you remember what to look at in the graph? All right. So let's try another one. We'll make it a little bit more complicated this time. We have a quadratic and a linear in this one. And we're going to use the same approach, right? Since both of these are equal to y, I can take these two functions and set them equal to each other. So I can do something like this. Negative 3x plus 10 equals negative 2x squared plus 9x minus 8, right? So I can set those equal to each other, draw my line, and begin putting this into a format that is advantageous for solving. All right, so since I have a quadratic, we like quadratics to be set equal to 0. All right, so I'm going to move everything on the left-hand side over to the right-hand side. So I'm going to start with this negative 3x. So I'm going to add 3x to both sides. And notice that I'm lining that up under the other term that has an x, right? Because I only want to add together like terms. All right, so these cancel. I get a 10. And then over here, I'm going to end up with negative 2x squared. This will combine to become 12x, and then we have minus 8. All right, so we're still not set equal to 0, so I'm going to move the 10. So I'm going to subtract 10 from both sides. And so 10 would be a like term with the negative 8 over here, so I'm going to line that up like so. So these cancel and become 0, which is what we wanted. We wanted a 0 on the left-hand side, and then we just work our way left to right here. So I got plus 12x, and if I do negative 8 minus 10, we'll get a negative 18. All right, so now that we are in this form, right, so now we've got a quadratic set equal to 0. You have two options to solve this thing. All right, you can use quadratic formula or you can use factoring. And as you know, in most of my videos, I'm always going to choose factoring if I can. It is just much quicker, much less prone to mistakes, and more fun. Okay. The drawback of factoring is that it doesn't always work. Right? We might run into some equations that are not factorable. Right? I believe this one is. So let's see what happens here. So we got negative 2x squared. We've got negative 18. And then middle term down here, I've got 12x. And then I'm going to multiply here so we get a positive 36x squared, right? Because negative times a negative is a positive. 2 times 18 is 36. And then we have the x squared. All right, so I'm looking for two numbers that multiply to 36 and add to 12. I think that should be pretty obvious, right? So 6x and 6x, right? 6 plus 6 is 12. 6 times 6 is 36. So here we go. So 6x and 6x. And then we need, so we have a negative 2x squared here, so we're going to need a negative 2x and an x. All right, and actually, for this one, it won't matter where you put the 2x and where you put the x, right? Because 2 will go into 2 and 6, and then 2 will go into 2 and 6. All right, so here we go. Let's see, so we got negative 2 times something gives me 6. Well, that's got to be 3. Right, so, and then over here, x times something gives me 6x. Well, that's got to be a 6. And there's my two factors. So I've got negative 2x plus 6. And then we have x plus 3. And this is still equal to 0, right? Set equal to 0. So now I got to take each of these, use zero product property, and set them equal to 0. So we've got negative 2x plus 6 equals 0, and x plus 3 equals 0. And then we solve each of these quickly. Okay, and then if we subtract 3 here, oh, this one's turned out to be rather interesting. Look at that, I got the same solution for x, right? So I got x equals negative 3 for for both of these. That's pretty interesting. So we're going to have one solution here. So x equals -3. Don't forget that you still have to find your y value. You can use either equation over here to help you find the y value. So I'm going to use the linear one because it's a little bit easier to work with. So I'm going to say y equals -3x plus 10, and remember now we know what x is, so I'm going to plug that -3 in for x. So we've got y equals -3 times -3 plus 10. Okay, and then we would multiply there, so you get y equals 9 plus 10, which is 19. So there it is. And we can write that as an intersection point, -3, comma, 19. Okay, and there we go. So depending on what MyOpenMath asks for, MyOpenMath might ask you for the intersection point, or they might ask you to separate your answers like this, where you have x equals, y equals. All right, just make sure you read the directions. All right, let's do another one. At problem C, we're going to use the same strategy that we used before, where we take the two functions and we set them equal to each other. All right, so I'm going to take this first one, the square root of 4 plus 2x, and I'm going to set it equal to x minus 2, just like I did in the previous problems. All right, I'm going to draw my line, and I'm going to start trying to move things around and manipulate this and see what happens. All right, so I notice over here on this side the x is trapped inside of the square root, so I want to get that square root out of there. So what I'm going to do to undo a square root, I have to square. All right, so I'm going to take this entire side and I'm going to square it. All right, because a square and a square root, they cancel out. They're opposite operations. All right, but whatever I do on one side, I have to do on the other side as well. So I'm going to square the x minus 2 on the right, and I'm going to work left right here. So the square root and the square, they cancel, leaving me with just 4 plus 2x. Now over here, it's a little bit more complicated. I'm going to use a box to help me out with this, because x minus 2 squared, x minus 2 squared is the same thing as saying x minus 2 times x minus 2. All right, it's multiplying two binomials there, so I'm going to set that multiplication up using my generic rectangle. So let's see what we get. We got x times x, which is x squared. We get -2x here, -2x here, and a positive 4 here. All right, so if I add those four boxes together, I get x squared minus 4x plus 4. Okay, so that would be x minus 2 squared. So now I've got a quadratic. Somehow I went from a square root to a quadratic, but that's okay. We know we like our quadratics set equal to 0, so I'm going to take this stuff over here, the 4 plus 2x, and I'm going to move it over here so that way we get a 0. So I'm going to start with the 2x. Let's see, these will cancel. So we get 4 equals, and we got x squared minus 6x, right? 4x minus 2x is minus 6x plus 4. Okay, and then we are going to subtract 4 from both sides. There we go. So the 4's will cancel. We get 0 equals x squared minus 6x, and then we'll get 4 minus 4, and that is just 0. So I'm just going to put a plus 0 here on the end. All right, so now that this thing is set equal to 0, you've got two options where you can either factor, or you can use quadratic formula to help you find the solutions to this equation. I like factoring, so I'm going to set up a box and diamond and see what this thing looks like. Diamond here, and we get x squared. We're going to put 0 in the bottom right hand corner, and we're going to take that -6, put it down here. When we multiply, we get 0x squared. So I'm looking for two numbers that multiply to 0 but add to give me a -6, and that's got to be 0 and -6. So I'm going to say 0x and -6x, and then we start filling in our side dimensions, right? So we got x, 0, and -6. We've got x plus 0 times x minus 6 equals 0. And if I solve these, we find that x equals 0 and x equals positive 6. So we get two solutions there. And what that means is we are going to get two corresponding y values for this one. So let's see what happens here. So I'm going to work with the second equation. I'm going to take a 0 and I'm going to plug it in. And I'm going to say, okay, well, 0 minus 2 is negative 2. So if I plug a 0 in, I get a negative 2 out for the y. So this is one complete solution. And then over here, if I take this 6 and I plug it in, we get 6 minus 2, which is 4. All right, so we have two solutions here, and I want to make sure that I take a look at the graph of this thing because there could be a possibility of extraneous solutions, so we need to make sure we double check that. Okay, so let's go to Desmos. Here we go. Let's type in our equation. All right, so we had 4 plus 2x, the square root. And then we had x minus 2. There we go. So I got them both graphed. And let's see here. So we've got, there's our solution at 6, 4. All right, so that was one of our solutions. The other solution, which was supposed to be at 0, negative 2, you'll notice that here at 0, the lines do not intersect here. All right, so there is no solution at the 0, negative 2. So what I'm going to do is I'm going to take this solution, the x equals 0, y equals negative 2, and make sure that I mark it as extraneous. Okay, so that one is an extraneous solution. This one is a good solution. Okay. All right, last problem I'm going to show you today with systems is this guy right here. Now this one's really cool. It uses a method called substitution method. All right, so if you look at it, it says y equals 2x minus 5. So it's telling us what y equals. So I'm going to take this 2x minus 5 and I'm going to use it in my first equation. See where it says y right here? All right, so since y is 2x minus 5, I'm going to replace that y with 2x minus 5. All right, so we get 4x minus 2, but instead of a y, I'm going to replace it with 2x minus 5. Right, and this is all equal to 10. And this gives me an equation that I can solve. All right, you might have noticed right off the bat, like this one wasn't like the other ones because it wasn't set up as a y equals like the other one. So I can't set these equal to each other like I did in the first three. So I have to use a different method, so we're using something called the substitution method. And that's where I take one of the variables and I substitute it with a different equation, right? Because it tells us what y is, so I can take this 2x minus 5 and substitute it in for y. Right? And now I have an equation, and I'm going to draw my line and I'm going to start solving here. So first thing I see here is parentheses, right? So I'm going to distribute this negative 2 into the parentheses to get rid of those. The 4x remains unchanged, so negative 2 times 2x is negative 4x, and negative 2 times 5 is a positive 10 equals 10. All right, so now if I do 4x minus 4x, well, that becomes 0. So we get 10 equals 10, which is kind of weird, right? We get a number equal to a number which is true. So what that means is any value of x or y would make this system true. So all values for x and y work. Right? It wouldn't matter what you plug in here. These two equations will always be equal to each other. All right, guys, that's it for today. If you have any questions, make sure you let me know in the Zoom chat. Have a great day.